This is a density column of dish soap, water, and vegetable oil. And the dish soap is green. So here's the dish soap, there's the water, there's the vegetable oil. Their order in the density column tells you their relative density. So since the dish soap is at the very bottom, it is the most dense. And since the vegetable oil is at the very top, it is the least dense. We can also compare densities of any other object we drop into the density column. So here's a penny. If I drop the penny into the density column, it sinks to the bottom. So its density has to be denser than all three liquids. Here's a rubber stopper. If I drop this into the density column, again, its density is more dense than all three liquids. I can also make a density column with hot and cold water. My cold water is dyed blue, my hot water is dyed yellow. I'll start by putting the cold water in the burette. And then we'll follow it with the hot water. As you can see, the cold water stays on the bottom. Cold water is more dense than hot water. The green area here shows the mixing zone. This is a great model of water columns that we can see in nature, in the ocean and in deep lakes, where we have the cold water settling in the bottom, the warm water on the top where it's warmed by the sun and the ambient air temperature. Here, where the mixing level occurs, where we have the transition between warm water and cold water, this is called the thermocline. And perhaps if you've been swimming in a deep body of water and you dive down deeper, where you go scuba diving, you can feel that cold water hitting your body. That's where you're transitioning into the thermocline. So density columns can also be made with hot and cold water because there is a big enough density difference between the cold water and between the hot water.